Greetings, math fans. All right, so today's lesson is more with radicals, but today's lesson is actually called Rationalizing Denominators. Okay, so let me write that down. Rationalizing Denominators. Okay, and this is day 5. Now, this is pretty scary sounding, right? Rationalizing denominators, like, what? That's an awful lot to say there. But really, this is the deal. There are no square roots on the bottom of the fraction. On the bottom of a fraction. That's the rule. Okay? No square roots in the bottom of the fraction. That's it. That's like the main thing. Okay, so if you give me an answer and it looks you got something like this on the bottom, wrong. No square roots in the bottom of the fraction. So my lesson today is how to get rid of those radicals in the denominator. Okay, that's the whole lesson today. All right. So let's do a problem here. So if I start out with how about the square root of 5 over the square root of 7? Okay, so I can't have that square root of 7 there. The only way to get rid of that square root of 7 is it's really simple, okay? And these are just for square roots. We're going to get into cube roots in a second here. But this is square root. What you want to do is you want to multiply the top and bottom by, in this case, the square root of 7. So whatever is under the square root in the bottom. So basically the bottom square root. That's what you want to multiply the top and the bottom by. Because watch what happens. If I multiply the top by square root of 7 and the bottom by square root of 7, this is what I want you to think here. First of all, let's look at the bottom here. The square root of 7 times the square root of 7. I know a lot of you guys want to say that's the square root of 49, which is what? 7. Hey, the square root's gone. That's cool. But here's the deal. You guys said the square root of 49. The way I want you to think about it is I want you to think about it as the square root of 7 times the square root of 7 is just 7. Okay, you can't think of the square root of 49, but you got to do a little extra work, and then you got to take the square root of 49. I just want you to think if it's the same square root, square root of 40 or square root of 7 times square root of 7 is just 7. So in other words, if I said square root of 17 times the square root of 17, I don't want you multiplying 17 times 17 and then taking the square root of it. I want you to tell me that's just equal to 17. Okay, so square root of 873 times the square root of 873 is 873. That's important. So if you multiply the square root, it's the same number. Square root of something times square root of something is something. Okay, the square root just goes away. Okay, and it doesn't mysteriously go away. It's basically saying, remember I told you back in the day, like, let's look at this guy right here. Okay, do you guys agree that square root of 17 is like saying 17 times 17 here? And remember, if you have a pair of something, you can take that out of the square root, and it just becomes 17. Okay? So that's what I just want you to remember. I know it's a lot of, I just kind of said a lot here, but basically, if you have the same number under the square root, it just becomes that number. If the square root goes away, because you have a pair of those numbers. Okay, so let's go back to our original problem. Square root of 5 over square root of 7 times root 7 over root 7. Okay, so square root of 7 times square root of 7 is just 7. Now the top is root 5 times root 7, which is root 35, right? 5 times 7 is 35. Guys, that's the answer to our problem. Please don't cancel stuff out. Don't cancel that 35 with the 7 out. If it's under the square root, it's all by itself. It doesn't. You can't do anything with something that's outside the square root versus something inside the square root. Okay? So like, for example, if I had let's say I had 14 here, I could simplify that then because these are both out of the square root. Okay? But anyway, the answer to this problem is square root of 35 over 7. So let's do another problem here. Okay, it's really not difficult, but remember, no square roots in the denominator. So square root of 13 divided by square root of 3. Okay, multiply the top and the bottom by square root of 3 over square root of 3. That gives me, you multiply these together, so that's the square root of 39. And on the bottom is just 3. That's it. You're done with the problem. What? It's pretty easy. Okay. Let's say I had 2 square root of 5 over 3 square root of 7. Okay, I'm going to multiply the top and the bottom by just the square root of 7 over square root of 7. I don't care that I have a 3 here. That 3 is just beautiful, just hanging out there, but I don't care. All right, so on the bottom, I get that 3 is still there, and now you multiply the square root of 7 times square root of 7, which is 7. And the top, square root of 5 times square root of 7 is square root of 35, so it's 2 square root of 35. So your final answer for this problem is 2 square root of 35 over 21. Okay? Pretty easy. So let's do a couple more here. So square root of, let's see, 2 square root of 3 divided by 5 square root of 6. Okay, well, that's pretty nice. This is going to be just a little bit more work, and I want to show you what's going to happen here. We're going to multiply by the square root of 6 over the square root of 6. So we get 2, and I'm not going to quite put this together yet. Even though you know we have to multiply this together, I'm going to leave it separately. So on the bottom I get 5 times what? 6, right? Now why did I leave this separate? Remember guys, again, you got to kind of pull stuff together again. It's 3 times 6. If I gave you a problem back in the day, first of all, 3 times 6 is 18. And you should be able to simplify square root of 18. You should think, remember I told you this, that 18 is 2 times 3 times 3. So I can pull out a 3. So the reason I didn't simplify this 3 times 6 is because I already broke it up. Why put it together again to give me 18 just to have to break it up again to say 2 times 3 times 3? Do you guys agree that top is really 2 or 3 times 2 times 3 over 30? And I got a pair of 3's. Remember I told you that? So take out the pair of 3's, and we got 3 times 2, and what's left over? A 2, and the bottom is 30. So 6 root 2 over 30. Now, do you guys think we're done? I mean, once again, guys, 6 over 30, you should be able to reduce that. Okay, at the end, put in your calculator. I don't hit the fraction button, but you should see 6 over 30 is 1/5. So this final answer is 1 root 2 over 5. And I don't care if you have the 1 there. That's no big deal. 1 root 2 over 5 or just root 2 over 5. Okay, that was a little more complicated because you could simplify that radical. But you're starting to pull stuff together, guys. Okay? Just have to remember, you always simplify your radical. That denominator radical is always going to go away, no matter what it is. I don't care what's in the denominator. If you multiply the top and the bottom by that radical, that radical is going to go away. And then you guys got to deal with the leftovers. Okay? All right, so let's do a problem where, and again, this is not a big deal. We did this previous lesson. If I said square root of 7 over 3. All right, this is again from last night's or the night before's homework or lesson. You got to rewrite this as square root of 7 over the square root of 3 before you can do anything. Okay, and now you write it as, I'm going to multiply by the square root of 3 over square root of 3. So that gives me square root of 7 times square root of 3, which you can't simplify at all, is the square root of 21. And the bottom is square root of 3 times square root of 3 is 3, and that's your answer. Again, please don't try to cancel something out now because that square root is on top, and then you have a whole number on the bottom, and there's no square root on the bottom, so you're done now. That's it. You can't cancel anything out. So square root of 21 over 3. Okay? It's not bad, right? But just remember, to be able to write it this way and then turn it to this, that's important. So then you can multiply that by square root of 3 over square root of 3. Okay? Let's just do one with variables in it too, and then we'll get into cube roots. Okay. All right. So if I had the square root of 5x to the 7th over the square root of 3x, or 3, let's say 3y cubed. Okay? So let's multiply it out. What I'm going to do is I'm going to multiply the top and the bottom by the square root of 3y cubed over the square root of 3y cubed. Okay? So that's pretty easy. So on the bottom, I should just get 3y cubed. Remember what I told you. If you multiply the same thing under the radical, it just becomes 3y cubed. Okay, the top, let's multiply it out. So we're going to get the square root of 5 times 3 is 15, x to the 7th, y to the 3rd. Okay, cool. So got to deal with the variables now, right? So this is like the old days. So let's just look at the top. So square root of 15 x7 y3 is 15 x to the 6th, x to the 1st, and y cubed is y squared times y to the 1st over 3y cubed. Okay, so remember at the top, you're going to take that x to the 6th out, so you get x cubed, 6 divided by 3, or sorry, 6 divided by 2 is 3, and you're going to take that y squared out. 2 divided by 2 is 1, so y to the 1, and that's all I can take out, and you have this stuff left over. You have the 15, you have x to the 1, and y to the 1 left over. So it's going to be 15xy, and the bottom is 3y cubed. Now what's the last thing I can do? Remember, you can only deal, like I can cancel anything out with that because that's out of the square root of the bottom. All right? So what can I take out of here? Well, you guys should say, oh wait, this is y to the 1, so I can cross this off, and that becomes y squared. Right? The bottom wins. If you do battle, the bottom wins by 2. So my final answer for this problem is x cubed times the square root of 15xy over 3y squared. Okay? All right, so that's it with square roots. Let's do cube roots. Okay, so let's do that. I think it's a little more challenging. We're only going to get to, you only do cube roots. So let's do that one. If I do the cube root of, let's say 5 over the cube root of 9. So remember how we had on the bottom, I multiplied the top and the bottom by whatever it was in that square root. So let me do this here. Let me do that. And I multiplied by square root of 3 over square root of 3. What that allowed me to get, guys, that allowed me to get a pair of 3's. You guys agree with that? That's why I could make that 3 on the bottom. That was our goal. So if I have a cube root, remember what we're looking for, right? What do you need in order to pull something out for a cube root? What do you need? You need 3 of a kind. You need 3 of that same number. So I want you guys to look, that top, I'm going to rewrite this as the cube root of 5. And the bottom, do you guys agree that 9 is 3 times 3? Okay, so in order to pull something out, I need the cube root of one more. I need to have another 3. So watch this. I'm going to multiply the top and the bottom by the cube root of 3. What that's going to give me is that's going to give me the cube root of 3 times 3 times 3, which is a perfect cube, right? It's 3 of those, so I can pull that out, which on the bottom I'm just going to get 3. That's kind of nice. That's my goal, is I want to get 3 of a kind to pull it out and not have a radical in the bottom anymore. And the top is 5 times 3 is 15, so the cube root of 15, and so that's just on top now. And that's my final answer. Cube root of 15 over 3. Okay? All right, that's not bad. So that was maybe a little complicated, but let's do a couple more problems. But remember, our goal is for a cube root is to get 3 of them on the bottom. The square root was to get 2 of them on the bottom. That's why I did square root of 3 times square root of 3. Goal with cube root is to get 3 of them on the bottom. Okay, so let's try that. Let's do the cube root of 7 divided by the cube root of, let's do 4. So we're going to do a couple different types of problems. So do you guys agree the cube root of 4 is really 2 times 2? And I can't do anything with the cube root of 7, so it's right out there. So what do I need? I need another 2. So I'm going to multiply it by the cube root of 2 over the cube root of 2. So that gives me, on the bottom now, this is really an equals here, right? And this is multiplication here. Okay, so on the bottom I get the cube root of 2 times 2 times 2. On the top I get the cube root of 14. So that's a perfect cube on the bottom. It's 3 of a kind, so I just get a 2 on the bottom. On the top I get the cube root of 14. And you're done with the problem. Okay? So let me do a little bit more complicated of a problem. Not really that much more, but let's say I do the cube root of 5 over the cube root of 6. So the first thing you notice, like with this 4 guys, this guy here, I was able to break it up into 2, and then I only need 1 more. Well, 6, I don't have that feature, right? I can't. 6 is 2 times 3, so that doesn't do any good. So here's the deal. In order to simplify this, I need to multiply it by the cube root. Do you guys agree I need 3 of these? So how about 2 more? That gives me 3. And so I'm going to multiply it by 2 more. Okay? So on the bottom, again, this is multiplication here. On the bottom, it gives me the cube root of 6 times 6 times 6. And on the top, it gives me the cube root of 5 times 6 times 6. Right? Again, I don't care. The top can have a cube root. That's cool. In fact, I multiply all that out, I'm going to get 180. Okay? Use your calculator to figure that out. The bottom, what am I going to get? 6. Looks complicated, but I'm sorry. The cube root of 6 times 6 times 6 is just 6. The cube root of 1.2 billion times 1.2 billion times 1.2 billion is 1.2 billion. Okay? So this is your final answer. You can't do anything else with this. Okay, so let's try another one of these. So let's do the cube root of, well, first of all, if I did this, let me do this first. The cube root of 3 over 5. So what I want to do is break it up to the cube root of 3 over the cube root of 5. Okay, so remember, I need the cube root of 3 of these. Okay, so I'm going to multiply the top and the bottom by the cube root of what? Well, I need 2 more of these, right? Okay, so on the bottom I have the cube root of 5 times 5 times 5. And on top, I have the cube root of 3 times 5 times 5. Okay? Is everybody okay? I hope you guys are okay with this. And so then the cube root of 5 times 5 times 5 is just 5. And on top, multiply all out. Because you can't simplify the top. I don't have 3 of them. So 3 times 5, 15. 15 times 5 is 75. So it's the cube root of 75. And you're done with the problem. Okay? All right, so that's really not bad. Let's throw a variable in there. I think it's important to throw a variable in there just to kind of show you guys you have a couple problems like that in your homework. Okay, so This is actually one of the problems, like your homework. So it's 1 over the cube root of xy. So I have no radical on the top, which is no big deal. But in order for me to simplify the bottom, I need an x cubed and I need a y cubed. So watch. I'm going to multiply the top and the bottom by the cube root of x squared y squared and the bottom by the cube root of x squared y squared. Because that's going to give me the cube root of x cubed y cubed, which is perfect because, so let me write the top here. This is going to be the cube root of x squared y squared. And the bottom is going to give you the cube root of x cubed y cubed. And you could, again, it's having like 3 of these. If you want to think about it, it's 1, 2, 3, and 1, 2, 3. So what if I multiply these together? I wrote it as this, guys, but truly it's just xy. Right? The cube root of x cubed is x, the cube root of y cubed is y. And then on top, it's the cube root of x squared y squared. Okay, you're always looking for perfect cubes on the bottom. That's the only way you get rid of a radical in the denominator. Okay? So here, let's do another one, again, similar to a homework problem. The cube root of 7x over 3y. Well, first of all, I'm going to do this. The cube root of 7x over this cube root of 3y. Okay? That 3y is the only thing I'm concerned about. The 7x, I don't care. So I need another 3y 2 times. Do you guys agree with that? I need a 3y and another 3y. That gives me 3y on the bottom. I'm not even going to write it up. I'm not even going to multiply that out. Because I need a 3y and a 3y. It's going to give me 3 of these. So that's just going to give me 3y on the bottom. And so let me write this here. 3y and 3y. And that's cube root, by the way. Okay? And so on the top, it's going to give me 7 times 3 is 21. And 21 times 3 is 63. Okay? So that's going to give me the cube root of 63 x y squared. It's really easier than you think, because sometimes kids get all crazy and you think it's complicated. It's not bad. We're just trying to get rid of the denominator on the bottom, and the top can be anything you want it to be. It doesn't really matter. Okay? And that's your final answer. All right, so I try to give you a bunch of different explanations with square roots or cube roots. Sometimes, I know this is a problem similar to your homework as well, so I'm going to do it. If you guys get a problem where, let's say, for example, I have the cube root of 5 over 10. Well, you could do this, the cube root of 5 over the cube root of 10, and then simplify it that way. So let's do it this way. I'm going to show you, actually, this is a more difficult way. But do you guys agree I need to multiply this by the cube root of 10 times 10 over the cube root of 10 times 10? So on the bottom, do you guys agree it's just going to be the cube root of 10, 10, 10, so it's basically 10? And the top, it's going to be 5 times 10 times 10. But watch this. I'm not going to combine it together because I can simplify it. So 5 times 10 is 2 times 5, and 10 is 2 times 5. So do you guys see that I have 3 5s here? And I can pull that out. So actually I get 5 times the cube root of 2 times 2 is 4 over 10 and that can cancel, right? The reduced 5 over 10 is 1/2, so I can really get the cube root of 4 over 2. That's my final answer. But watch, if I recognize right in the beginning, look at the original problem here, guys. Look at the original problem. Okay, what do I have? 5 over 10. Isn't that 1/2? So watch. How about if I rewrite this as the cube root of 1/2? Boy, that makes it a lot easier. If you can reduce the fraction ahead of time, check this out. The cube root of 1 over the cube root of 2. What's the cube root of 1? That's 1. That's easy. Well, the cube root of 2, okay, so what do I have to multiply the top and the bottom by? I need 3 2's. So 2 times 2, and this is 2 times 2. So what do I have in the bottom? If I have 3 2's, don't multiply it together, just tell me it's 2. And what do I have on the top? Well, 1 times that is the cube root of 4. What? These are the same. So you tell me which is easier. I think this bottom method right here is easier. And the only reason is because here I had, square root of 5, and I had 10s. I had to do a lot of simplifying just to have to cancel at the end. This one I canceled early. I simplified early, and then I just did the problem, and my final answer here, I didn't have to do any kind of simplifying. It just came out to be root 4 over 2, and that was it. Okay? All right. So, it's a little complicated, but hopefully you guys are good to go with the stuff, and I did a ton of examples, a lot of examples very similar to your homework, and hopefully you guys are good to go with this, all right? Well, that's it, math fans. You have an outstanding day. Adios. Goodbye.